Hello, scholars. Today we're going to be starting a new unit, Unit 4. This is on page 132 of your Illustrative Mathematics Algebra 1 student workbook. Please flip to page 132. Grab a highlighter. We're going to be talking about describing and graphing situations, and we're going to look at some fun functions around us to describe them. So we got done with a chapter on equations, and now we're starting to talk about this thing called functions. Let's see what we remember from middle school. And here comes our warm up. A customer is at a bagel shop trying to buy 13 bagels, and the shopkeeper says that would be $16.25. But the three friends who are there think that's a mistake. Jada says, I think it should be $13.25. Priya says 13, and Han says, no, I think it should be $11.25. So pause the video now and see if you can figure out what prices were they putting together to get those three different scenarios. Who's right, or could they all be right? Okay, let's see how you did. So what if they just went straight down to this 12 bagels for $10 and then the additional bagel was $1.25? Did you guys get that? Han, that's where he got his $11.25. Then for the $13.25 one up here, Jada did 6 bagels, and then the one additional bagel. So that's 6 and 6 makes 12, and then $1.25. That's what makes our $13.25. So then what did Priya do? Priya took the 9 bagel cost and then added 1, 2, 3, 4 additional bagels. And that 4 times $1.25, that's going to make $2.50. $2.50 and $2.50 is $5. $5 and 8 makes the 13. So technically, they're all right. They all used different prices off of the list correctly. So they could all be right. Over here on the side, the number of the bagels and this table for cost, we could fill this in going down incrementally, meaning one bagel is $1.25, and then we keep adding. But then we get to 6 bagels, we see that price decrease right here, where it jumps down to $6 for 6 bagels. So it's like a savings, right? Then we would add 125 again till we get to the $9 mark, and there we go again with the $8. So it's better just to get that discount of $8. And then we keep adding 125 again till we get the deal for 12 bagels, and that was $10. So again, if you're filling this table in from the pricing, you're going to notice that it goes at a constant rate until a certain number, but then it has these jumps that take you back down to a certain price. So there's actually multiple ways that this table could have been filled in depending on how you are using, if you're using the shopkeeper's price, Jada's price, Priya's price, Han's price. But really what we want to be looking at is the best price. So how'd you do? Did you come up with that on your own for the warm-up? All right, there's 2 sections in our lesson today to start talking about functions. Let's look at the 1.2, be right back. 3 days in a row, a dog owner tied his 5-foot-long leash to a post outside a store when he ran into the store to get a drink. Each time the owner returned within minutes. The dog's movement each day is described. Day 1, the dog walked around the entire time while waiting for its owner. Day 2, the dog walked around the first minute, then laid down until the owner returned. Day 3, the dog tried to follow its owner into the store but was stopped by the leash and started walking around the post in one direction. Kept walking until its leash was completely wound up around the post. The dog stayed there until the owner returned. Each day, the dog was 1.5 feet away from the post when the owner left, and each day, 60 seconds after the owner left, the dog was 4 feet from the post. So let's go put those coordinates on the graph. Pause the video and try it yourself, and let's see how you did. 60 seconds after, 4 feet from the post, and 1.5 feet when the owner left. So you're going to go look and analyze those days. You can choose one to specifically look at. So say you choose day 1. Day 1, the dog walked around the entire time while the owner was there. So you're supposed to come up with a graph of what you think could be happening as time is passing. They're 1.5 from the post. Do you see them moving farther, farther, farther away and then getting closer, closer, closer as time goes on, or something like that? How do you want to make your graph? Do you think the dog's doing some weird, like wiggly stuff, right? We don't actually know what the dog did. We're just given 2 points in time and then you create a graph. If you wanted to pick day 2 or day 3, feel free, and you could sketch a graph for this. Why, by the way, is my graph connected? My graph is connected because the time in seconds is continuous. Time is continuously passing. So I'm going to make that continuous line of what's happening. Well, here's a couple sample graphs that students may have come up with um, for the day 2 or the day 3. What do you think? How'd your graph look? Did you make a nice squiggly line? All right, let's talk about this function. So the two pairs of quantity from the situation we saw, each pair has a relationship. Time in seconds since the dog owner left and the total number of the times barked, or the time in seconds since the owner left and the total distance in feet that the dog has walked. In that function, so choose one pair of quantities. So by the way, you're going to pick either the first one or the second one. So if we want to say the first pair of quantities, let me go ahead and type some sample responses in here. Font's a little bit too big. All right, so we could say something like the time in seconds since the owner left is independent. The total number of times the dog has barked is dependent. So they're barking if they're taking a longer time. So the total number of times the dog barked is dependent. So then we're going to write a sentence in the form of blank is a function of blank. Okay, how'd you do? Do you understand what's a function of what based on our statement? Okay, and then they want you to go down and sketch a possible graph of this scenario. So I want you to picture that as time is passing, the dog barking are these little sporadic, like bark, bark. So picture, let's label on the side the number of barks. And along the bottom is the time passing in seconds. And you can count by any scale, but say you're like 3, 6, 9, 12, 15, 18, and along the bottom 20, 40, like in seconds, 60, 80. Luckily, it's not very long, right? Okay, so let's say that after 10 seconds, the dog barks 2 times, and then they bark 2 times after 20 seconds, and then after 30 seconds, they bark, and then after 40 seconds, they bark. And then it's kind of just like this sporadic, like little barking stuff that's happening. These are all the little barks. So these little dots, these little discrete graph represents like bark, 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 bark as he's walking away. If you happen to choose the other function, there's a little sample graph here of time in seconds since the owner left and the dog walking around that little pole. So that would be a continuous function of the dog walking, 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 depending on the one you chose. Now, after going through these just sort of brief function descriptions here, they want you to go back to your middle school definitions and see if you remember this. The relationship between two quantities is a function if there's exactly one output for each input. At the end of each lesson, we should always go to the summaries and highlight these vocabulary words and make sure we remember these. So, if there's exactly one output for each input, for every x, there's only one y. We call the input the independent variable and the output is the dependent. These two quantities form a function if the time is independent variable and the height is the dependent. This is because any amount of time. Take a minute to read through the rest of the summary and highlight important points. Look and analyze the graph to end our lesson.